So it's that time. It's finals season. Kill me. And I didn't think there's much sense in making a video on how I plan on preparing for my vector calculus exam, because that's more or less the same as, the one that I made for calculus. But I thought I would make one for group theory, or my abstract algebra course, because that's a little bit different than what I would normally do, just because the type of class that it is and the format of the class and the subject matter is a little bit different, presented a little differently than general math like calculus. I thought I would run through how I plan on preparing for this exam. I've started doing it, but I still have a lot more to do. Obviously, I've planned out many dozens of hours to prepare for this. I have a little less than a week now. The first thing I've done is write down all of the key terms from all of the pertinent sections, which is a lot. It's about between 20 and 30 big terms and concepts. I pulled them from my homework questions. I have them all digitally. I didn't want to pull them from the book, because if I pull them from the book, one, it'll probably take longer to find them because my book is terrible and it doesn't like bold words or whatever. But also because if I find them out of the book, then the definition is going to be next to them. And the whole point of me writing down this list of just the terms is so that I can go back and write in the definitions myself from memory as best I can. And once I do that, then I can figure out, where I'm lacking and what I don't remember. Then I can look up a definition and I can write it in. Then maybe I can study that list, put it away, go study for another class, and then come back to it and do that again. Try and write them all from memory and, keep doing that. So that's one part of it. And the other part is writing down questions. So a lot of those will be from homework. Some of them will be from my books. Other ones will be from exams. And I wanted to do that independently of concepts and terms, because for some of the concepts and terms, their definition gives away how to do them. Like if you have the definition of a group, if you know what a group is, and then you have a question which asks you to verify whether or not a structure is a group, then it's just a matter of applying the definition, right? Same thing goes for the kernel of a homomorphism, or a homomorphism itself, or an automorphism, or an isomorphism, or a coset for that matter. And that's probably a third of the terms. If you know the definition and you really understand it, then it tells you how to apply it to the problem. But there's another half which, even if you have the definition and you know it and you know what it means, it doesn't tell you how to solve the problem. So if you have something like find all the subgroups of a certain group that are of a particular order. So you can know what a group is, you can know what a subgroup is, you can know the order of an element, but that doesn't tell you how many groups there should be of each individual order. So you got to know both in that instance. So that's why I'm doing them separately like that. It's a little bit redundant, but it doesn't hurt. Once I have the list of all those questions, I'm going to treat it similarly to the concepts and terms, and I'm going to try and write out how I would do those in as much detail as possible. I don't want to, kid myself into thinking I'm really bad about saying, yeah, this question, and I know how to do it. I don't need to write it out. That's something very simple. And more often than not, it comes back to bite me in the ass, because, I'll just forget. I might know it right now. I definitely know it right now, theoretically, but will I a week from now or come test day? I don't know, but writing it is definitely going to aid in retention and memory and stuff like that. So I'm going to write out how to do those problems in grave detail. And then once I have those started, and I can, like I did with the terms and concepts, I can go back and fill those in with ones that I don't remember, and then study it for a little while, and then put it away, come back to it later, and try and do it again from memory and stuff like that. And then beyond that, I'm going to run through my notes, which are already pretty well boiled down, and I'm going to pull from those all of the important theorems and rules, corollaries, things like that help in doing problems, because those make all the difference in the world, especially when it comes to proofs because my exams are basically half and half computational and proof based. And there's a lot more points to be gained from proofs, and and frankly, they're just more difficult. There's more nuance to them, obviously. But knowing proofs or knowing theorems and corollaries and stuff helps with those a lot. Anyone who's done any kind of proof writing knows that. So I'm going to write all of those down, and obviously try and remember them as much as I can, and try and pick out the ones that are the most important. Probably one or two from each section if I can. And I might try and find a way to quiz myself on those. I don't know. I might just try and remember a couple from each section, like write down a section number and what topics that covers, and try and remember those most important theorems from that section. But I don't know. That remains to be seen. Still got to figure that out. And then once I have that, I'll mix that up with the terms and concepts and the procedures and how to answer those specific questions that I think are important or relevant, and that'll probably come up on the final. I'll probably go through and find a bunch of proofs to do. I'll probably pull some from old homeworks, because even though I did it on a homework, if that was a month or two ago, I probably don't remember how I did it. And I have the answers to all of the homework, so I can verify if I'm going down the right avenue. Because really nothing substitutes good hard practice, especially for proofs. Because more so than knowing the material, it's just knowing how to get from one point to another and trying to make those leaps and get what you want. So that'll be that, and that'll probably take a large amount of time, because I take a long time on proofs. That's something that I definitely need to work on, that I recognize. And I'll probably intersperse proofs with all of these other things, and that'll probably constitute most of my studying. So terms and knowing their definition, like their formal definitions, whether that's in set notation or it's just words or whatever symbols are associated with those, like the actual definition, not something paraphrased, because I feel like that could come and bite me in the butt if I don't write down something exactly as it should be. It's written that way for a reason, right? So between that and the procedures for my questions and doing practice computations and practice proofs, I think that will probably encompass most of my studying for this class. So yeah, that's more or less it for that course. If there's any interest later on, like maybe during winter break, I can make a video or two and I can do some of these proofs on camera for algebra, for group theory. I know it was the ones that I did for the algebraic proofs were relatively popular, and I can do the same thing for this if there's any interest. So just let me know in the comments or whatever. But anywho, that's more or less all I got. Thanks for watching. See you next time.